Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Nof Ahmed Al Yazid Al Yafri, and this is my teammate,
Asya Abdel Fattah Al Hajj.
and we are the designers of STEP AI solar thermal energy powered autonomous irrigation using AI for sustainable farming in Qatar. And our supervisors are Dr. Kishore Kumar and Miss Iman Zahdi.
Our problem is the Middle East is struggling with water, temperature, and limited arable land. Our main goal is to reduce water usage and optimize crop production.
Our objectives: designing a thermoelectric devices for harnessing solar thermal energy to generate electricity using AI, developing and programming a microcontrol-based automated irrigation system based on moisture in the soil, proof of the concept of the sustainable crop farming prototype by powering it with thermoelectricity produced from the assembly in the prototype.
Our hot climate is creating a negative impact to our environment, such as excessive water loss, soil moisture depletion, and heat stress, which reduces crop yield and quality. To address the issue, we created STEP AI. The system uses the sun's thermal energy in order to generate electricity for automated irrigation based on soil's moisture. And it also filters household water for irrigation and displays humidity levels. Our project achieves the seventh goal of the Sustainable Development Goals, which states affordable and clean energy.
And now, the importance of our research. Firstly, sustainability and recycling, and that include thermoelectric prototypes, provide shade and convert sun's thermal energy into electricity, and water waste reduction. Secondly, renewable energy and social impact, which is sustainability and social impact that appears as benefiting low-income communities. And finally, food security sustainable goals, Qatar Vision 2030, which is food security and being part of Qatar Vision 2030 and that enhancing energy efficiency and ensuring a prosperous future of Qatar.
We've compared our project with similar products, like Vertigo Australia, Coyote, and Trent Hunter. We went through different stages in order to reach to our final proposal.
As you can see here, we start with our first stage, involves analyzing the output voltage generated by filter device using solar thermal energy. When an electric current flows through materials, heat is absorbed on one side and released on the other side, and that output voltage generated by the device was then measured using a multimeter.
In our second stage, we started assembling our thermal electrical module using 4 Peltier devices. Our main components were 4 Peltier devices, 4 thermal fins, 2 metal plates, and thermal paste. The assembly process started with coating the 4 Peltier devices with thermal paste on the top. We located the 4 thermal fins at the bottom of the Peltier devices. The inner surfaces of the metal plates were also coated with thermal paste, and the Peltier device with attached thermal fins were then placed onto the metal plates one by one.
As you can see here, we're testing our device. This is an experiment set up to analyze the voltage generated while heating one side on the Peltier device, focusing the sunlight using a focusing lens.
In our fourth stage, silicone cooling capsules were implemented to enhance the cooling of the bottom surface of the Peltier device. The top part of our device is the hot part, where the thermal energy is absorbed from the sun. The bottom part is our cold part due to the efficient cooling to maximize the temperature difference. Coolant-soaked silicone balls were used for this purpose. As the balls were soaked in the coolant for 24 hours, then crushed and placed on the voids of the fins. Finally, the bottom surface was sealed with a metal plate coated with thermal paste.
As you can see here, our fifth stage was an initial testing of the fabricated thermoelectric model. Of course, the sunlight was focused on the top of the metal plate by a focusing lens, and the output voltage was measured with a multimeter.
As you can see in our sixth stage, we used the 3D printing to develop the enclosed box structure to embed the thermoelectric modules in the soil and trap the difference of heat from exposing. The design was made using Fusion 360.
The Arduino was our seventh stage. The various components of the autonomous irrigation system are listed here in the table that shows the connection of the components with the Arduino board and the programming of the microcontrol board with Arduino software.
In our final stage, we tested our soil moisture sensor by examining the data before and after dipping it in water as shown in the figures. We also went through the programming of autonomous irrigation module. The 2D illustration indicates the drafts of Step AI prototype. And these are the programming codes we used in order to program. And this is the flowchart that explains the mechanism or the process of irrigation.
And finally, here's the research result. Our device has achieved at least 60% of the required goals. As you can see here, the comparison between the draft prototype and the advanced device that we have finished till now with Qatar University Research Center.
And this is the survey we distributed to Hasad. Here's our project budget in Qatari riyals. We estimated the cost of our product, Step AI, will be about 2,500 riyal Qatari, and it can be available in local markets for 3,000 riyal Qatari. And here are our recommendations. Thank you for watching, and thank you for believing in young innovators.